Okay, from what concept we are studying about yesterday, just to remind you, non-polar, like we are studying the bond between hydrogen, one pair of electron is shared. So hydrogen nucleus contains one proton, the other hydrogen nucleus is also containing one proton. So there is a mutual sharing. The shared pair of electron does not move anywhere. So there is no distribution charge, and this is what is normal that you are studying. Now let's take the example of HCl, the formation HCl, how it is formed. Hydrogen has got one valence electron, the chlorine is having 7 valence electron. To get the stable configuration, hydrogen is sharing its electron with chlorine, and the chlorine shares the electron with hydrogen. So it goes like this way: hydrogen, single bond chlorine. This is how HCl is formed. Concept is clear now? Hydrogen has got the orbit completed with first shell 2 electrons. Chlorine is having 18 electrons, orbit is completed. So remember the bonding principle. Every participating atom needs to get the stable electronic configuration. Hydrogen has got the stable configuration of helium, and chlorine has the stable configuration of argon. It is stable. So HCl molecule is formed. Now in this situation, the sharing is little bit unequal. Now why it is so? I'll explain. Remember, every atom has got its nucleus. So hydrogen's nucleus is having one proton. The chlorine's nucleus is having 17 protons. Hydrogen has got one proton in its nucleus. Chlorine has got 17 protons. Now, what is taking place? The 17 protons attract this shared pair of electron, and one proton of hydrogen attract the shared pair of electron. Among these two atoms, the problem is with this one pair of electron. And that one pair of electron is attracted by 17 protons, or in fact chlorine's nucleus, and that is attracted with the hydrogen's nucleus. Understood it clearly? This one pair of electron is attracted by the nucleus of chlorine, nucleus of hydrogen. And who exerts larger force of attraction? The larger force of attraction is exerted, you can understand it, that is exerted by chlorine, isn't it? 17 protons, 17 positive charge is much larger than that of one positive charge. So therefore, what is likely to take place? This shared pair of electron, instead of being over here, it will be slightly moving towards chlorine. It is slightly moving towards chlorine. It is not shifted. Remember how we are shown about NaCl. NaCl is shown this way. It is transferred. That means electron is given forever. And here it is not transferring. The position of electron from this hydrogen is moving slightly towards the atom which has got more positive charge. Chlorine is having more positive charge, more protons in its nucleus. Therefore, chlorine exerts larger force of attraction to the shared pair of electron, due to which the electron is slightly shifting towards chlorine. I did not say transfer. In this one, what I said, the electron is transferred, it is given forever. Sodium has given its electron to chlorine forever. And here in this situation, the position of hydrogen is slightly shifted towards chlorine. Position of electron is shifted towards chlorine. Why chlorine? Chlorine is having larger force. And when this electron is shifted towards chlorine, what happens? The hydrogen will be developing what is said delta positive. Delta means very minute, very less. Hydrogen develops delta positive charge, and the chlorine will be developing delta minus charge. So therefore, what we can say, the sharing is unequal. And this type of covalent bond is known as polar covalent bond. Just compare it. Compare that situation with hydrogen molecule. In hydrogen molecule, do you think the shared pair of electron will shift anywhere? Each side the force of attraction is the same. So the shared pair of electron will remain then and there. It is not going to shift anywhere. And in this situation, what has happened? Chlorine is having very larger force than that of hydrogen. So the shared pair of electron will be slightly shifted towards chlorine. And when the electron is shifted towards chlorine, the chlorine develops Full negative, it does not have a full negative charge. Here in this situation, what happened? Fluorine is 1 full minus, hydrogen is full plus, because electron is given. And in this situation, this hydrogen, the chlorine develops slight negative charge. That is what is written in the Greek letter. This is delta minus, and hydrogen develops delta positive charge. So, though the electrons are shared, but the sharing is unequal, and such type of covalent bond is known as polar covalent bond. Understood it? Remember, you just follow about what we have studied it earlier. Non-polar is the one where the sharing is equal. Atoms of the same element, if the electrons are shared, sharing is equal, no differentiation of charge, and that becomes non-polar. And different elements are sharing the electron. Naturally, what happens? Different elements means different nuclear charge, different force of attraction. So it is understood who is mightier towards that side, the electron will be moving, electron will be shifted. So the sharing is unequal. Normally, when we used to take the class, I take this common example. Suppose like if you have been given 100 rupees and it is asked to share between two friends. 100 rupees is given and asked you to share between two people. So normally you say it is 50-50. That is, sharing is equal. Whereas in this situation, what has happened? The mightier person has kept 99 rupees and 1 rupee is given to the weaker one. Possible? That is also sharing, isn't it? It has been asked you to share 100 rupees. You can share either 50. Two people are stronger enough. One cannot fight with the other. Okay, you will be giving. Okay, you take 50, I take 50. 50-50. Sharing is equal. And if you are mightier and the other person is weak, you know that you can fight with that person. So what do? You keep 90 rupees. Okay, you keep 10 rupees. So you are shared that, and that sharing is unequal. And whereas 50-50 sharing. And in this situation, what has happened? The sharing is unequal, isn't it? One pair of electron which is present between these two, which is between them. But what has happened? Major part from the position being over here, it is slightly shifted towards chlorine. So that sharing is unequal. This chlorine keeps 90% of electron and only 10% is given to hydrogen. Isn't it so? Sharing is unequal, and that type of covalent bond is known as polar covalent bond. Understood? I'll take one more example. H2O. See, when we are studying about ionic compound, I have told you ionic compounds are soluble in polar solvents like water. Remember the statement? Now, polar solvents, it was only water is polar. And what makes water polar? Oxygen has got 6 electrons in the outermost orbit, that are the valence electron. Hydrogen has got 1 electron. Hydrogen is having 1 electron. So what is likely to take place? The sharing between the hydrogen and oxygen. Hydrogen shares its electron with the oxygen. So hydrogen's orbit is complete. Hydrogen needs to get 2 electrons in the orbit is complete. And when hydrogen is sharing the electron with oxygen, oxygen will have to share electron with hydrogen. So this oxygen is sharing the electron with hydrogen. Understood it? So this hydrogen's work is completed, stable configuration. The next hydrogen, it also shares its 1 electron with the hydrogen as well with the oxygen. So hydrogen has got a stable configuration. And then what is this oxygen? Since it has shared the electron, hydrogen has shared the electron of oxygen, the oxygen needs to share the electron of hydrogen, so therefore the sharing goes like this way. Now hydrogen's orbit is complete. Hydrogen's orbit is complete. Oxygen's orbit is also complete. So what we say, hydrogen has single covalent bond with oxygen, and this oxygen has single covalent with hydrogen. And this is the structure of H2O molecule. Understood? Remember, hydrogen needs 1 electron, so you are sharing 1 electron with oxygen. Oxygen needs 2 electrons to complete the orbit. So oxygen shares its 1 electron each with hydrogen. Don't say that oxygen shares 2 electrons with hydrogen. Understood? Hydrogen has only 1 electron. Oxygen cannot share 2 electrons with that. So oxygen shares 1 electron each with hydrogen. Understood it? So the structure is known. This is how H2O is formed. Now further understand what makes H2O polar. Why we say H2O is polar? Say this one. Hydrogen, as I told you, which it has got only one proton in its nucleus, this only one proton, and oxygen has got 8 protons in its nucleus. Oxygen exerts a larger force of attraction. Therefore, what is likely to take place? The hydrogen's electron will shift towards oxygen. This hydrogen's electron will be shifting towards oxygen, and when the electron is shifted, hydrogen develops delta positive. This hydrogen is also developing delta positive, and this oxygen develops 2 delta minus, isn't it? Understand? How much amount of positive charge the electropositive one gets? It's same amount of charge the other one gets in the minus charge. So this becomes positive. This is oxygen gets negative. So what has happened? The sharing has become unequal. Have you understood? And therefore we say H2O is polar. Understood clearly? See what has happened? Electrons are shared. As I told you, 100 rupees have to be shared 50-50. That becomes equal. If 100 rupees to be shared 90 plus 10, that sharing is little partial, isn't it? You say always partial. This is partiality that is shown in the sharing. The electrons which should have been there, but who is mightier towards that nucleus electron is slightly shifted it, and that makes sharing unequal, and there was such type of covalent bond is known as polar covalent compounds. Understood it clearly? So write down. The covalent bond formed between atoms of dissimilar elements. The covalent bond formed between atoms of dissimilar elements. Covalent bond formed between atoms of dissimilar elements is polar covalent bond. Polar covalent bond. In this case, the shared pair of electrons, shared pair of electrons will shift towards the atom which has got more protons in its nucleus. Will shift towards the atom which has more protons in its nucleus. Making the sharing unequal. The less electropositive nucleus gets slight positive charge. The less electropositive nucleus gets slight positive charge, and more electropositive nucleus gets slight negative charge. Thereby the participating atoms get slight positive, and the other atom gets slight negative charge. Participating atom gets light positive and the other atom gets light negative charge. Clear about polar one? Understood it clearly? H2O is polar, HCl is polar, SBr is polar, sulfur trioxide is polar. Any covalent bond which is formed between atoms of dissimilar elements. We can understand the concept clearly. An atom is identified by its atomic number. Am I right? An atomic number means it is a number of protons present in the nucleus or number of electrons. So two different atom means two different number of protons. That means the force of attraction is different. That means the shared pair of electron is partial, and that becomes a polar covalent bond. And when the sharing is equal, as in this case of oxygen, electrons are equally attracted by this. There is no partiality. That becomes non-polar. In HCl, chlorine is mightier. Therefore, the electron will go towards chlorine. Understand? Remember, it is covalent. It is sharing. So don't ever say that it is transferred. If you say that in ionic, in covalent, polar covalent compound, electrons are transferred, that answer is absolutely wrong. Understood it? Transfer takes place only in ionic compound. Remember. Now let's make some other molecules. Taking the example, let's take carbon dioxide. All these molecules, how it is formed, you have to understand it. Carbon has got 4 valence electrons in the outermost orbit. Remember, first 20 elements you should know. Nobody is going to give you the atomic number of first 20 elements. That you should know. So carbon's atomic number is 6, electronic configuration 2,4. Oxygen has 8 electrons. So 6 electrons in the outermost shell. So oxygen shares its 2 electrons with carbon. The oxygen's orbit is complete. And when oxygen is sharing the electron with carbon, carbon needs to share the same electron. Here also oxygen comes 2, 4, 6. It is sharing its electron with the carbon, and the carbon is sharing its electron with the oxygen. So oxygen circle has got 8 electrons. Carbon circle is also having 8 electrons. Therefore, what is formed? Carbon double bond to the oxygen. This is how carbon dioxide is formed. Let's take somebody was asking, let's take the case of nitrogen NS3. Nitrogen's atomic number is 2,5 electronic configuration. Valence shell has got 1, 2, 3, 4, 5 electrons. So it is sharing its electron with the hydrogen this way. It is sharing its electron with the hydrogen this way, and it is sharing. The electrons are sharing, so hydrogen has got the stable configuration. Octet is complete. And if hydrogen shares the electron with nitrogen, then nitrogen needs to share the same electron. The sharing goes like this way. Now, nitrogen circle, how many electrons are there? So all the participating atoms are the same configuration. So we write it as N single bond hydrogen, single bond hydrogen, single bond hydrogen. This is NS3. And in this one, carbons double bond with oxygen, double bond with oxygen. So in case it is asked, how many bonds are there in carbon monoxide? Sorry, carbon dioxide. Don't say that 4 bonds are there. How many bonds are there? Carbon has 1 double bond with 1 oxygen atom, and to the other oxygen atom is also having double bond. It is not single bond. Understood? Don't say that 4 bonds are there. When we say 4 bond means it is 4 single covalent bond. And how many bonds are there in ammonia? Nitrogen has single covalent bond with 3 hydrogen atoms. Is it clear? So don't say that nitrogen has triple bond with hydrogen. See, remember, covalent bond is always formed between 2 atoms. Understood it? So nitrogen, 1 single bond with hydrogen, single bond with atoms. So what is happening? 1 nitrogen atom has got 3 single covalent bond with single covalent with 3 hydrogen atoms. Whereas in carbon dioxide, one carbon has one double bond, or 2 double bonds with 2 oxygen atoms, or one double bond with 1 oxygen and one double bond with 1. Understood it clearly? Taking one more example. Taking the case of, let's say, methane, mass gas, natural gas, CH4. Carbon has got 4 valence electrons in the outermost orbit. Hydrogen has only 1 electron. Sharing is going this way. Hydrogen is having 1 valence electron shared. Hydrogen is having 1 valence electron. When the hydrogen are sharing electrons with carbon, then carbon needs to share the electron with hydrogen. So what has happened? The carbon will be sharing its electron with hydrogen. So hydrogen subject is complete. Carbon subject, hydrogen subject is complete. I mean, carbon subject is complete. So we will be having it in the structure like this way: carbon, single bond with hydrogen, single bond with hydrogen, single bond with hydrogen. This is how methane is formed. Methane, marsh gas. Simplest I don't have. Understood it well? Clear how the bond is formed? Remember the basic principle of chemical bonding. The participating atoms must get the stable electronic configuration. Understood it? So whatever atoms are present, every atom is getting a stable configuration. I'll give you certain molecules to be formed. Next, write down the properties of covalent compounds. The properties of covalent compounds. Properties of covalent compounds. When we did that ionic compound, I had told you, remember, ionic compounds are made up of ions. Between ions, there is a larger force of attraction. This also I told you. So when sodium chloride is taken, that sodium chloride contains number of Na plus and Cl minus. So each Na plus is attracted by number of Cl minus. And that is how, what we say, covalent compounds are crystalline solid. Like if it is Na plus Cl minus, Cl minus Na plus, so Na plus Cl minus, in this one, among the ions, larger force of attraction. And in this covalent molecule, what takes you? Now, take the example of hydrogen. This is one hydrogen molecule. There is a force of attraction between atoms of hydrogen in this molecule. There is a force of attraction between atoms of hydrogen in this molecule. And between these two hydrogen molecules, the force of attraction is very, very weak. This is 1s2 molecule. Among these hydrogen atoms, the force of attraction is also weak. Remember, the strongest force of attraction is between positive and negative. Understood it? The strongest force of attraction is between ions, cations and anions. Ionic bond, the force of attraction is very strong. And here what is taking place? There is no difference of charge. The force of attraction between them is very, very weak. So, what has happened? This molecule is free to move out, this molecule is free to move out. Therefore, since the weaker force of attraction between them, the force of attraction is weak. Therefore, covalent molecules are generally not solid. Not solid means, what can we say? They are in the form of liquid solid gases. Understood it clearly? Around the force of attraction between the covalent molecules is very weak. Force of attraction between the covalent molecules is very weak, making each of the molecule to move out easily, making each of the molecules to move out easily. Therefore, covalent compounds are not generally solid. Covalent compounds are not generally solids, or what do we say? They are liquids or gases. Covalent compounds are not they are not solid, or in other words, they are liquids or gases. Done? And if they are liquids or gases, what is likely to take place? They have low melting and boiling point. You know? We have studied solids have got higher melting point. Now, if covalent molecules, covalent compounds are not solid, they are liquids or gases. That means naturally it is understood their melting point and boiling point is very low. Now, why this? Remember, in ionic compound, I told you why are ionic compounds are having high melting point? Because when all these ions stay together, give them rigidity. Now, here what has happened? This molecule is free, this molecule is free, all these molecules are individual, they are separate, they have got their own identity. Each one is able to move out by themselves. That means when we give little bit of energy, if liquid, they get converted into gases. Understood? And if by chance if they are in the form of solid, little energy is given, they melt to be converted into liquid. So covalent compounds are generally liquids or gases, and since they are liquids or gases mean their melting and boiling point is very low. Clear? Now, see easier method to remember the properties. You study the properties of ionic compound. We have studied that its opposite is for covalent. So simple. Ionic compounds are electrically charged ions, it was having stronger force, therefore they are solid. Covalent compound, there are no ions, weaker force, therefore they are liquids or gases. Stronger energy, larger amount of energy is needed to break the bond, and here each of the molecules are, this covalent molecule, they are free to move apart. That means covalent molecules are having low melting and boiling point. Next one. Ionic compounds are good electrolyte, we are studied. Good electrolytes. What are electrolytes? Electrolytes are compounds which are having ions. Compounds which conduct electricity. Electricity is getting conducted two things. Remember, long time back I told you. For anything, electricity is to be passed. What is needed? Either it must have free electrons or it must have ions, isn't it? Metals are good conductors of electricity because metals are mobile or free electrons. Non-metals are bad conductors because they don't have any mobile or free electrons. Ionic compounds are good electrolyte because they are made up of ions, electrically charged particles in molten or solution form. It is in the form of ion, therefore it can conduct electricity. And covalent compounds, what has happened? It does not contain any ions, it does not have any charge, therefore they are generally bad electrolyte. Understood it? Ionic compounds are good, again and again I am telling you, ionic compounds are good electrolyte because they contain ions. Covalent compounds are bad electrolyte because they don't contain any electrically charged ions. Therefore, they are bad electrolytes. Understood it? The next one, ionic compounds are, what we are studying it? Ionic compounds properties. What was the next property? Solids we have studied, liquids, low melting and boiling point. Ionic compounds are soluble in, you don't study polar solvents like water. Polar solvents like water. That means covalent compounds are insoluble in water. Ionic compounds are generally soluble in water, and its opposite. Covalent compounds are insoluble. But remember, some of the covalent compounds are highly soluble, that is separate one. Chlorine is soluble in water. Remember, first chapter we have studied it when we learned about the bleaching powder. Chlorine dissolves in water due to chemical reaction. What happened? Chlorine plus H2O, remember that? Plus H2O will be getting HCl plus HOCl. This is chemical reaction. So chlorine is soluble. Ammonia, we have studied it. Ammonia is highly soluble in water. NH3 plus H2O will be forming NH4OH. Chemical reaction. So, whenever we study the properties, you must mention it that they are generally, covalent compounds are generally insoluble in water. Ionic compounds are generally soluble in water. Understood? For example, alcohol, ethyl alcohol is highly soluble in water. Miscible liquids, you have studied in 9th standard. Miscible liquids can be separated by distillation, isn't it? Alcohol and water, they are highly soluble to each other. They don't get separated each other. So highly soluble. So covalent compounds are generally insoluble in water. Understood it? Oxygen is sparingly soluble. Hydrogen is insoluble. Understood it? Nitrogen is insoluble. There are some covalent compounds which are soluble in water. That is exceptional case. And ionic compounds are generally soluble. Some of the ionic compounds are also insoluble. So these are the properties of covalent and ionic compounds and covalent compounds. Understood it? The structure of these molecules are to be made. You make the structure of these molecules. Something I have given it. All these NS3, H2O, carbon dioxide, CH4, CCl4, these all structures you make it. I am going to give you a little bit more. C2H6, C2H6, that is ethane, will be selling on this compound, C2H6. H2S, hydrogen sulfide. C2H4 and C2H2. These compounds, structure you make it. Now remember, anything you do it, I don't mind about it. You do anything. But remember, the participating atoms need to get the stable configuration. The first one, see 2 carbon atoms and 6 hydrogen atoms. You arrange hydrogen atoms in such a way that hydrogen get the stable configuration, carbon also should get the same. Now when you talk about C2H4, there are 2 hydrogen atoms less. You distribute the hydrogen atoms in such a way that it gets the stable configuration, as well as carbon also should get it. So don't ever think that among the carbon atoms also there is a bonding possible. When there are number of carbon atoms in a compound, among the carbon atom also there exists a bonding. So remember that. If there are 5 carbon atoms in a compound, among that 5 carbon atoms there exists a sharing. So that all will be, you make this structure for the time being. Okay?